So now that we have learned how to factor, it's time to do a review of what we have learned and sort of process this into some steps. We should know by now that the first step in factoring a polynomial of any kind is to look to see if there are any common factors, and if there are, we need to factor out the GCF. Once you factor out the GCF, you then need to look at the polynomial to see how many terms there are in it. If it's a monomial, binomial, trinomial, polynomial, um, we need to see. So a binomial would have two terms in that. And so for binomials, we have three formulas. We have a difference of two squares. And if you have an a squared minus a b squared, it will factor by saying a plus b and a minus b. And if you have a difference of two cubes, that's a perfect cube minus another perfect cube, you would say a minus b and then multiply that by your a squared plus a times b plus your b squared. And then if you have a sum of two cubes, that's when you have two cubes that are added together, you would say a plus b and then multiply that by a squared minus a times b plus b squared. Now, if there are three terms, that's a trinomial. So you can try using those two formulas that we learned for perfect square trinomials. Now, most of the trinomials that you encounter will not be perfect square trinomials, but if you have a perfect square in the front and the back, and 2 times your a, which that's your perfect square in your front, the square root of the perfect square in the front, and b, which is the square root of the perfect square in the back, if it fits that formula, then you would just say a plus b squared. Now, the only difference in this next formula, I mean, it's the same thing except it's minus 2ab. So the way that you would factor this is a minus b squared. Now, if your trinomial does not fit the perfect square trinomial formulas, then you could try to use the methods and should try to use the methods that we learned in 6.2 and 6.3. If there are 4 or more terms, we factor it by grouping. And that's what we learned in 6.1. Now, see if there are any factors in the factored polynomial that can be factored further. You're going to have to do that every now and then. And then we check by multiplying it all out. So let's work a couple examples and think through this list. Keep this list handy as we go through some examples in our review. Our first example in our review is going to be 4x squared minus 8xy minus 3x plus 6y. So the first step says to look to see if there are any common factors. If so, factor it out. There is no common factor, and therefore there's no GCF. So now I have to look and see how many terms are in this polynomial, and there are 4 terms. And part C says if there are 4 or more terms, we factor by grouping. So let's group this together. And on this first part, I'm going to factor out a GCF of, in this first binomial, I'm going to factor out a GCF of 4 and x. I have two x's in common, and my lowest power of x is 1. So x to the first power is the GCF. Once I pull out the GCF of 4x, I'm left with x minus 8xy divided by 4x is 2y. Now in this next binomial, I have a 3. That is my GCF, but because the 3 right here is negative, I'm going to pull out a negative 3 instead of a positive 3. And I will be left with x minus 2y. So now I have an x minus 2y in common, and I'm just left with 4x minus 3. In our next example of 125 minus 8y cubed, I look to see if there's a GCF, and I really want there to be because 125 is pretty large, but there is not one. And so then I'll go straight to looking for how many terms are in the polynomial, and there's 2. So it's a binomial. Now, it does not fit a difference of two squares. It is a difference formula. It is a difference problem, but they're not two squares because I have a y cubed. I can't use it. So then I go to a difference of two cubes, and I see the y cubed, and I think, okay, well, yeah, that is that's a perfect cube, and I know that 8's a perfect cube because the cube root of 8 is 2. And then 125, I just check in my calculator because I can't think off the top of my head. But 125 there is a perfect cube as well. So I can rewrite this to fit the difference of cube formula by saying that this, instead of 125, is 5 cubed, because 5 cubed is 125, minus 2y cubed, because 2y cubed is 8y cubed. And so essentially this equals this. I mean, it's the same thing. And now this fits my difference of cubes formula. So the formula says a cubed minus b cubed equals a minus b times a squared minus, plus ab plus b squared. So my a is 5. My b is 2y. A squared, that'd be 5 squared, is 25, plus 2y times 5 is 10y. And then b squared, 2y squared is 4y squared. So that would be my answer. In our next example, 4x cubed plus 20x squared minus 56. I know 56x. I can see that there's a GCF of x, and 4 goes into 4, 4 goes into 20, and 4 goes into 56 14 times. So I can pull out a 4, and I would be left with x squared plus 5x minus 14. So now I want to try to factor what is left, and I have to look and see how many terms is in the polynomial that follows. And it is a trinomial, and it says in my notes for the integrated review, in my steps, it says to first try to factor that trinomial using the perfect square trinomials, but I can't do that because 14 is not a perfect square. X squared is a perfect square, but 14 is not. So I can't factor it using the perfect square trinomial formulas. So I'm going to have to use those old-fashioned methods and multiply a times c to get negative 14. And my factors of a negative 14 that add to give me 5. Well, if it's a negative 14, multiplying to get a negative number tells me that they're going to be two different signs. And because they're two different signs that add to give me a positive number, that tells me that my largest sign will be, my largest number will be positive. So 1 times, negative 1 times 14, and negative 2 times 7, right here. This is where it's at, negative 2 and 7. So I take negative 2 and 7, put them off to the side, and put x in the denominator, 1x. And they don't simplify, so it's x minus 2 and x plus 7, and we cannot forget our GCF of 4x. In our last example, let's see if there's some room. There we go. We have 2xy minus 72x cubed y. And I looked to see if there's a GCF, and I can see that they're both even numbers, so I know they have a GCF of a 2, and in x, the lowest power of x is to the first power. When I do this, I'm left with, ooh, they also have a y in common. Look at there. I'm left with 1 minus 36x squared. And I have to look at what's left once I factor out my GCF to see if it fits any, to see if it'll factor. And the first step I do there is look to see how many terms there are. There are 2 terms, so I need to see if it fits any of these formulas for a binomial. And see, it's not going to fit a difference of cubes or a sum of cubes because this is a squared, because of the x squared. It will fit a difference of squares formula because 1 squared is 1, and then 6x squared is 36x squared. So my formula for a difference of squares is a squared minus b squared equals a plus b, a minus b. So a is 1, 6x is b. And then do not forget your GCF of 2xy.